My name is Mr. Kangas, and today we're going to be taking a look at really two different sections, Chapter 1, Section 6, and Chapter 2, Section 6. These two sections both address the coordinate plane, or graphing. So I'm going to be addressing them today both at once. I'm not sure why they're in different chapters. So, first things first is we just need to know what is a coordinate plane. So, most of us have seen one of these before, and this is the coordinate plane. And on the coordinate plane, we usually plot points, or we graph points, and each of these points is made of an ordered pair. I'm going to discuss what all this stuff is as we go along. First things first, though, is we need to know what each of these lines represents. The vertical line, or the line going up and down, is known as the y-axis. The horizontal line, or the line going left and right, is known as the x-axis. Now, before I was talking about how on the coordinate plane you have a bunch of points, and points are graphed with ordered pairs, or points are made up of ordered pairs. Now, what is an ordered pair? An ordered pair is a set of coordinates, an x-coordinate and a y-coordinate, that leads you to a point. They're kind of like directions, you could say. X-coordinates travel along the x-axis. They move left and right. This is stuff you should probably be taking notes on. So again, the x-coordinate, or the x-coordinates, move left and right on the x-axis. Y-coordinates move up and down on the y-axis. So together, they're able to lead you to a point on the coordinate plane. For example, if I had an ordered pair of 3, 5, the x-coordinate always comes first in an ordered pair. When you see an ordered pair, the first number is always an x-coordinate. The second number is always a y-coordinate, something you should have notes on. So the first number is always an x-coordinate. The second number is always a y-coordinate. So the first number moves you left and right. The first number is telling us to move, the first number here is telling us to move right 3 spaces. Positive numbers move to the right. Negative numbers move to the left. So if we go over 1, 2, 3 spaces, we'll have used the x-coordinates directions. Y-coordinates move up and down. They move on the x-axis. Now a positive y-coordinate would move us up. It's like an increase or a gain. And a negative y-coordinate would move us down. Okay. A negative y-coordinate would move us below what is called the origin, or center point. The origin has an ordered pair of 0, 0. So if you have not moved up or down, and if you have not moved left or right, you would be at the origin, or the beginning. So according to this ordered pair I wrote up earlier, I would move positive 3 spaces, so right 3 spaces to the right, okay? And I would move positive 5 spaces. So I would move up 1, 2, 3, 4, 5 spaces. And so this ordered pair represents this point. So that's how you would graph an ordered pair. The first number moves you left or right, depending on whether or not it is negative or positive. The second number moves you up or down, depending on whether or not it is positive or negative. So let's graph a point that has a negative in it. So this point has an x-coordinate of -2 and a y-coordinate of +6. So we move left 1, 2 spaces, because negative numbers, just like on the number line, negative numbers move to the left. So we move left 1, 2 spaces, and we move up 1, 2, 3, 4, 5, 6 spaces on the y-axis. And that's where the ordered pair, -2, +6, would end up. So again, these coordinates, these x-coordinates and y-coordinates inside the ordered pair, really are kind of like directions telling you where to go, how to get there. A lot of times you'll see a coordinate grid or coordinate plane when you're looking at a GPS, when you're looking at a map. Okay, the latitude and longitude on a map actually represent a coordinate grid or a coordinate plane. So the x and y axis are kind of like latitude and longitude. So just a quick refresher, this middle point here is the origin. Its ordered pair is 0, 0. We haven't moved left or right, we haven't moved up or down, we're right at the beginning. The y-axis moves up and down. It's that middle line here, that blue line right here, moving up and down. And y-coordinates move up and down just like the y-axis. So y-coordinates move along the y-axis. The x-axis moves left and right. So x-coordinates also move left and right. They move along the x-axis. Negative numbers on the x-axis move to the left. Positive numbers move to the right. Negative numbers on the y-axis move down. Positive numbers move up. One way to think of it is typically if you are going down, okay, you're losing altitude. If you're in a plane and you go down, you're losing altitude. And if you're losing something, it's kind of like a negative number. But if you're gaining altitude, it's kind of like a positive number. It's an increase. We typically associate increases with rises, so moving up. Moving upward is typically a positive direction, and moving down is typically a negative direction. As far as the x-axis goes, it's just like a number line. The right side is the positives, the left side is the negatives. So, what I've shown you so far is not only I've shown you so far how to graph an ordered pair. So if you have an ordered pair of 3, 5, you would move to the right 1, 2, 3 spaces. Then the y-coordinate would tell you to move up 1, 2, 3, 4, 5 spaces, and that's where the point would be. You can also use this information to take a look at a point and figure out what its ordered pair is. Let's say you don't have the ordered pair, but you have the point. Well, here's the point. So if I wanted to make its ordered pair, I would go 1, 2, 3, and I would see that when I move over 3 spaces, I'm lined up with my point, so I would know my x-axis, or not my x-axis, I would know that my x-coordinate is 3, because I moved over 1, 2, 3 spaces to become aligned with my point. And from there, I would go up 1, 2, 3, 4, 5 spaces. So I had to move up 5 spaces to meet my point. And that's how I would write out the ordered pair of the point if I was not given that information already. So the last thing I'm going to talk about in terms of the coordinate plane and graphing is the quadrants. There are 4 quadrants. That's where the word quad comes from. Quad means 4. So we have 4 different spaces on the coordinate plane. There are 4 different spaces on the coordinate plane, and we have given labels to these different quadrants because it makes it easier to talk about a set of data or a set of points. When you have a bunch of points on the graph, it's easier to talk about these points And it's easier to refer to different parts of the coordinate plane when you have labels for the different parts. Each quadrant has specific features about the kinds of points that you will find in them. So if you take a look at quadrant 1, in order to be in quadrant 1, you need to move to the right and you need to move up. So to be in quadrant 1, your x coordinate needs to be positive and your y coordinate needs to be positive. So to be in quadrant 1, both coordinate pairs need to be positive. So both your x and y coordinate need to be positive. To be in quadrant 2, your x coordinate, so you have to move left to be in quadrant 2, so your x coordinate needs to be negative. But you still have to move up to get into quadrant 2. So your y coordinate would need to be positive. So again, this is something you should be taking notes on as well. So to be in quadrant 2, your x coordinate needs to be negative and your y coordinate needs to be positive. So the types of points you're going to see in quadrant 2 are going to have negative x coordinates and positive y coordinates. So you might see something like -3, +5, for example. To be in quadrant 3, both your x coordinate and your y coordinate would need to be negative because you are moving left and down. Left is the negative direction on the x-axis, down is the negative direction on the y-axis. And to be in quadrant 4, you would have to have a positive x-coordinate because you're moving to the right, and a negative y-coordinate because you're going down. So not only do we have labels for the different quadrants or the different pieces of our coordinate grid, but we also have specific characteristics that belong to each one's points. Remember, every point has an ordered pair, and every ordered pair has an x and a y coordinate. And so to be in quadrant 4, our x coordinate has to be positive because we have to move to the right to be in quadrant 4, and we have to move down to be in quadrant 4, which means our y coordinates need to be negative. As we jump into the algebra, coordinate planes are going to be more and more important. We're going to talk about something in chapter 7 called a linear equation. And when you see a linear equation, you will always see two variables. You will see an x and you will see a y. They won't always have the x first and the y second. But we'll talk about that when we get to chapter 7. So when you have a linear equation, we'll just do a simple one. We're just going to do x plus y. I was going to put a number next to the x and a number next to the y, but we're going to make this simple because this is the first time you're being introduced to this. But when you have a linear equation such as this one here, we have x plus y equals 5. X and y were specifically chosen. They're not just random letters or variables that were chosen. We chose x and y because x represents the x coordinates of ordered pairs and the y represents the y coordinate of ordered pairs. So when your x and y coordinates add up to +5, that creates an ordered pair that is, or a point that is on this line. So this equation represents a line. So, for example, we can make what's called a t-chart. that has my x coordinates and my y coordinates listed. So if I plug in 3 for x, then my y has to be 2 because 3 plus 2 equals 5. So one of the points on this line that this equation represents is positive 3, positive 2. So I'd move over 1, 2, 3, up 1, 2. Another point I could make, let's say I plugged in 1, positive 1 for x. Then my y would have to be positive 4, because 1 plus 4 is 5. So I'd go over 1, right 1, up 1, 2, 3, 4. Now let's try a negative. What if my x coordinate was negative 1? Negative 1 plus positive 6 would get me positive 5 for an answer. So negative 1 plus positive 6 would get me positive 5 for an answer. So I would go left 1 because my x coordinate is negative 1. And I would go up 6. So I'd go up 1, 2, 3, 4, 5, 6. And we'll do one more point. What if we had an x coordinate of positive 7? In order to get an x coordinate of positive 7, to make this equal to positive 5, y would have to be negative 2. So over here I have what's called a t-chart. This is a list of ordered pairs that satisfy this equation. They make this equation true. Not only do these ordered pairs make this equation true, but they're also all part of the same line. So let's plot this last point, 1, 2, 3, 4, 5, 6, 7, down 1, 2. And as you can see, all the points, or all the ordered pairs that satisfy this equation, are all part of the same line. Right there. That's something we'll talk more about when we get into chapter 7. But it's something I wanted to kind of preview today because we are talking about graphing. And I think this is a simple enough concept that we can at least introduce it right now. And we can talk in more detail about it when we get to chapter 7. So that's really all there is to chapters 1-6 and chapters 2-6. So this video just kind of hit 2 birds with 1 stone. So if you're looking at this video and you're on chapter 1-6, this same video will also be posted under the chapter 2-6 section. So keep that in mind as you progress. But tune in for the next video.